Thanks, Andrew. Yes, what we're going to do today, as I say, as Andrew said, is to look at a number of different sorts of research we're doing in this group. And in particular, we're going to focus on quantitative techniques. And we're going to do around 4 short talks about different application areas. And I think the 2 things we want to focus on is the actual areas we're studying, but also why we're using the particular techniques that we're using. So it's a bit of a portfolio of what we do and how we do it, and try to get across a bit why we're doing it that way as well. So that's in a nutshell what we're going to do. And I'm going to start off first talk, and that's basically about working with what's called citizen science data, and I'll explain some of those ideas now. So, well, first of all, I guess most researchers have to use data in some way. And what I want to talk about here, particularly about quantitative data and about a particular kind of quantitative data, are 3 sort of ideas. And they're linked, but they are distinct. So I'll try and explain the difference between them. And those 3 ideas are what's called open data, volunteer geographical information, and citizen science data. And then I want to talk a bit about how I'm using this data to approach a particular research question, and also what that might mean in terms of the data analysis I'm using, and how the fact I'm working with this kind of data means I have to think about what kind of analysis I'm going to use, and I can't just apply something just out of the box that wasn't designed for that kind of data. And this is the example I'm going to be using, which is actually looking at climate change through citizen science. The basic idea here is we've got people who have been observing the first bloom dates of lilacs. They've been doing this in the US for about 50 years. And what we're interested in is this first bloom date gradually getting earlier? And if it is, then that's some sort of evidence of climate change. And there's other sort of indicators as well that have been used, and we want to see how this links with those ideas. So first of all, just this general idea of open data. Now, open data is really more of a government initiative. It's saying that a lot of data that's frequently been collected by institutions, and particularly by the government, by the Office for National Statistics and various other government institutions, the police, the Home Office and so forth, is now being made freely available. So that, for example, they're releasing the crime data in this crime.uk website, so you can see things like where different crimes have actually occurred. So, for example, you can get a map here, and you can get these indicators of how many crimes have occurred near. Now, there's been a few problems with the way that's displayed, and that's not something I'll go into today, but it does actually illustrate the fact that when you're either visualising or analysing this data, you do have to do it appropriately. This is actually where I live, so there won't be too many crimes there, I hope, but we'll see. Another example of this, perhaps on a more local approach, is the Greater Manchester Data Store. Now, this is actually a portal. Rather than covering a particular kind of data, like just data about crimes, this is actually a portal to all kinds of different social and economic data, largely in and around the Manchester area. And from this, you can access lots of different kinds of data. And the point is, as well as just making this data available so that people can just see it listed, it's possible to access the data, put it through various kinds of software, analyse it, map it using geographical information systems, and so forth. So, for example, I can produce a map like that, which was actually the rates of deliberate fires committed on other people's property per 1,000 properties in the Greater Manchester area. And I can produce a map like that from that data. So I can kind of take the data from the website and produce maps like this. And as well as just producing maps, I can statistically analyse it and so forth. And that's just one example. There are thousands of different things I could get from that database and come up with maps, something like that. So as a source of data, it's quite important. There's suddenly lots and lots of data that would have been quite difficult to get hold of before, if not impossible. And without that, without this sort of initiative, it would be much harder for people to access this. So that's basically open data as an idea. Another kind of data that is also freely available is what's called volunteer geographical information. And that's different in that rather than being produced by governments and institutions, these are just members of the public, not particularly part of any official process, that are giving this kind of data. And for example, it's been described as the widespread engagement of large numbers of private citizens, often with little in the way of formal qualifications, in the creation of geographic information which was a function that for centuries had been reserved to official agencies. Now, one quite good example of that is OpenStreetMap, where people have been getting iPhones and various other kinds of systems with a GPS on them, recording where streets are and putting that up to some sort of central repository. And on a voluntary basis, someone's actually organising that and producing websites like this. So as well as having to get data from someone like the Ordnance Survey or from Google Maps, you can get this data which is actually entirely no strings attached. So it's very, very sort of open, and there's no conditions on what you can do with it or anything like that. You can pretty much use that for whatever you want. But it's a different form of open data in that it's basically something that is just being collected on a purely voluntary basis. There's no sort of government agency overseeing this, unlike, say, the Ordnance Survey, which does a similar thing, but certainly used to charge very, very large amounts of money for people to access it. And so that brings us to the third idea, and that's data that comes from what's called citizen science. And this is an example of citizen science data, and it's perhaps somewhere in between the two extremes that I've given there. On the one hand, you've got open government data that's collected by official sources. You've got volunteer geographical information just by untrained citizens. And somewhere in between, you get this idea of volunteer geographical information as citizen science, where people who are interested in a particular subject undergo some sort of brief training in order to collect the data, but then actually collect it. So some examples in the UK, they have a number of ones to do with watching for different breeds of birds in different parts of the country. And people are given some sort of training so that they can identify which birds they are and things like that. So it's not quite as sort of unskilled as something like OpenStreetMap. But on the other hand, what it means is with that small amount of training given to a very large number of people, you can actually get quite a lot of data in that way. And it's not as free in terms of its cost as volunteer geographical information. Someone's probably got to pay to organise an initiative like that, but nevertheless it's quite a useful and very powerful resource for obtaining information. And that's the sort of data I want to talk about here. And in particular, as a geographer, one of the things I'm interested in is looking for spatial patterns and possibly also temporal patterns in my data. And there are lots of techniques in geography and in quantitative geography for analysing these kinds of patterns. But what I want to do is to be able to analyse these in some way that actually takes into account the fact that I'm working with this citizen science data. And one of the problems is that in a lot of situations, and this is the thing I want to focus on now, in statistical analysis there's a concept of experimental design. You come up with some sort of way in which you're going to collect the data. And often, certainly with volunteer geographical information, you've got none. You can't tell people, just people voluntarily provide this data. You don't really have much control what data you get, where you get it from, when you get it, things like that. And even with the citizen science, although you've got some more degree of sort of control over that, again, it's really being done on a voluntary basis by people, so you don't get the same degree of control as if you were just organising a standard sort of experiment or a standard piece of social research. And there's two other related issues to that, which I'll probably focus on less. One is metadata. That's basically saying that you need to know something about the way the data was collected if you're going to analyse it. I'll touch briefly on that. And there's a broader issue, which I won't really touch on today, and that's actually openness in the analysis as well as in the collection of the data. If I'm going to publish on this, it's probably fitting for me to explain exactly how I've obtained my figures. So we're going to go on to, as I mentioned earlier, this idea of looking at the first bloom dates of the North American lilac. Basically, what's happened, this is a classic citizen science project. It's actually been around a very long while, and it started off in one part of the US and gradually spread across the whole US. But this actually happened in the 1950s. It wasn't to do with climate change or anything like that. It was just interest in actually the plants themselves, and people who are interested in plants and in gardening that set up these networks, and they were just interested in mapping these patterns. They talk about something called the green wave, which is as you go across the US, you get things differently blooming at different times of the spring. And there's a website where you can volunteer this kind of information. Again, there's training that's available now on the website, although obviously in the 1950s it wasn't done in that way. It was actually done by people actually showing people how to identify the lilac, what they meant by first bloom date and things of that sort. And we've got this data that you can download off the web though, and there's data for the years from 1956 to 2003. They're at just over 1,100 observation centres. It's across the whole of the US, with 1 or 2 observations not in the US. And there's about 14,000 observations. Observation stations, I mean, it's the individual places. So there's obviously more than one observation from a lot of places because people have observed more than 1 year in the same place. And there's roughly, on average, about 14 observations from each place. And we also know their latitude and longitude. Now, if we're going to look at this first off, okay, don't worry too much about the maths for the moment. This is a plot of year against first bloom date, and these are the spread of the observations that we actually got. And if you try to fit a line through those, you see it's ever so slightly going upwards. It's a bit surprising, but that makes it look as though the actual first bloom date is getting later as time goes on. So rather than thinking about global warming, it looks rather like things are getting colder, that spring's actually coming later each year, which is the wrong way around from what you'd expect. And if you look at the calibration of that model, that's the thing you want to look at there, and it's positive as a number. It really ought to be negative according to people's expectations. If you're thinking about climate change, the last thing you'd expect is for that to have a significant positive slope. So what's going on there is a rather surprising result. So, you know, why is that? Well, okay, one thing we could do is say, well, okay, it might just be that all these theories about global warming are completely wrong, and in fact we're heading towards a second ice age. The trouble with that is it doesn't fit in very nicely with all of the other observations and theories that have been seen, some of which suggest that nothing's happened, other things suggest that global warming is happening, but nothing seems to suggest that it's actually getting colder. So we want to think about our data and how evenly balanced are the observations is the issue in this case. And we want to think about what sort of geographical effects might influence the first bloom date. So I've already said that probably it's going to be different in different parts of the US. And yet when I drew that graph, I only looked at the first bloom date and the year it was observed. I didn't take into account anything about the spatial location. So what happens if I do actually do that? Well, what I can do is look at this plot here, and that's actually telling you the longitude. So that's basically how far east or west the observations were, and which year they were observed in. And what you'll notice is that at certain times, certain areas were well represented and then they weren't. And in fact, what you can see here is, for example, when you're on the on the west coast, it all seems to stop a bit around about there. And furthermore, when you're on the east coast, you don't get much in the early days before about 1960. And there's reasons for that. And again, this is just to do with the fact that it is this citizen science kind of data. First of all, the people on the basically the idea spread from the west coast to the east, and so people didn't uptake it on the east coast until later on. That's why there's fewer observations on that side. Secondly, the initiative was actually state funded, it was I think state funded for quite a long time, and that cut out in about the mid-90s, and that's where there were no more observations. A few interested individuals managed to get it started up again a bit later on, but you can see there's that gap there and that gap there. Now, the problem is that basically spring tends to come earlier in the west than in the east. So if I don't take into account where the observations were, you will actually get, as time got later, you got more observations in the east. So when I was drawing my graph, although I was just doing things on time, I was also moving from window a bit from west to east, which was causing the spring date to get later. So how can I get round that? Well, one of the things I can do is to fit something called a random coefficient model, and what that basically does, it tries to estimate two things. One is this slope of change, but B, to understand that even if things are changing over time, as well as that effect, there is the fact that the that spring comes at different times in different parts of the US, and effectively what we've got here is this map sort of shows for each of the observation stations a colour coding telling you when spring arrives, and basically it definitely arrives earlier along the west coast there. So you can see that, and if you take that into account and do it, then basically what now happens is, without getting too much into the maths, what we really wanted to happen there is for that quantity to be negative, which it is. And basically that's important, and in fact what that interprets as is that the first bloom date is getting earlier on average by about 1 day every 6 years. But when I did this, I've allowed for this imbalance and the fact that these things happened with the data collection, that things were cut out at certain times, and in different parts of the US they were cut out. And so, just to conclude then, the key thing here is that you do have to work without experimental design. You have to work understanding the fact that things like this you don't really have much control over. You get what data you can, and it's still a great resource. It's just that you've got to remember that if you're going to do that, you've got to make sure you use an appropriate statistical technique, and if you don't, then you could actually get very silly conclusions. And also people talk a lot about data mining, you know, this idea of throwing algorithms at data to find out what patterns are in there. And if you take the mining analogy a bit further, people used to talk about fool's gold. You know, I think it was iron pyrites, when you skim for gold when you were mining and you found something you thought was gold and got very excited about it, it turns out not to be. That's what you can do quite easily with data mining when you don't take into account the sort of story of how the data was collected. And so I suppose my final sentence really is just to point out therefore that statistical analysis is always an aid to an intelligent thought. It shouldn't be a substitute for it. So on that note, I'll conclude and I'll hand over to Dr. Alex Singleton, my colleague.
Okay, something completely different, but sort of related. There's some references from Chris there as well.
Yeah, sorry for those.
I was going to talk to you today very briefly about what is sort of collectively referred to as neogeography. It's a definition of neogeography which I came up with a couple of years ago, and a couple of years before me, a chap called Andy Turner in the US wrote a book for one of the sort of computer series of books about neogeography, and it was the idea that it was a new sort of emerging paradigm in how we go about doing mapping on the internet. So Chris has actually showed you a couple of examples of neogeography already in passing. Some of you may well remember websites like this. This was the multi-map website which existed probably up until sort of the mid-2000s, around 2004. And if you remember, if you've ever used a website like this, they look very different from the types of mapping websites you might see today. Interacting with this was quite difficult. You would typically enter a search term. The whole web page would refresh. You'd be presented with a map. If you decided, oh, I've searched for the wrong location, in order to manoeuvre the map to a different part of, just an example of London, you'd have to click on one of these arrows. Potentially the whole web page would refresh. You get a new bit, and the user interaction with the map really wasn't that simple to use. I sort of refer to it as being sort of like watching black and white television. Then along came around 2004, 2005, what we now refer to as web mapping 2.0. And this is probably what you're more familiar with when we talk about online maps. This is just a normal, again, the similar area of London, a Google map. The things that have changed about the way in which we interact with the maps now, we've got the ability to search particular locations without having to refresh the whole web page. We get a zoom in the map is interactive. To a specific part of London you might be interested in this case. You have the ability to pan and zoom, so it's called what you call slippy maps. You can click your mouse, you can drag the map around. It appears seamless, it's like you've got a huge map in front of you. The way in which, the main reason why this happened was changes in web browser technology and spatial data infrastructure which sits behind that technology, which actually enabled these types of representations to be created. So principally what you have is a very, very large map at a very high spatial resolution for the whole of the UK, or the whole of the globe in this Google Maps. It's sliced up into lots of squares. You can't see all of those squares, but each one of these blocks here represents a square, so that's actually one image there, that would be another image, that would be another image. And it also, which is the clever bit, it loads similar images for the bits in the map you can't see. So when you move the map across, there's no delay in refreshing the map. And that's why it's called a slippy map. So, with these new types of maps which has been merged, the clever bit was the infrastructure which went behind them, which allowed you to use some of this base data, some of this basic cartographic data, to put some of your own data on top of it. So you can actually, map patterns of crime on top of it. You can map where the GPs are, and this type of mapping capability was enabled through application programming interfaces, which are basically, it's a jazzy way of it wraps up a lot of the hard things about putting points on a map, makes it very, very easy. It's actually now not very difficult at all to put your own data on top of, for example, a Google map. Now what I want to go on to is just showing a couple of examples from my own research. I'm just going to attempt to get a web browser up, which is always in danger when you do live demonstrations. Just a couple of examples of neogeography, which I've used in my own research, which I think illustrate the types of things that you can do in your own projects. Now, these particular examples are ones which I've developed with a computer scientist, so it's actually reasonably technical to get this level of interaction on these types of maps. However, that said, if you weren't a technical user, you didn't have access to a sort of tame computer scientist, there are lots of packages available now which make this type of thing, perhaps not to this level of interactivity, reasonably simple. As simple as using Microsoft Word based on Euclid, and you can have a nice map online. So it's like a good top, is what I would say. So this is the first example, which was an ESRC funded project, which took spatial data about people's performance in schools. So this was a raw data set. Had a record for every pupil in England in state schools, where they lived, and what they did at school, and how well they did in their exams. And what we can do with that series of spatial processes, we aggregated it together into something we thought was safe to put in line, and we can actually integrate it into one of these neogeography type websites. So let's have a look. And what this is showing you here, that's why it's loading up, is it's a map which is these are geographical areas showing you the percentage of 5A to Cs, and it's divided into deciles, highest grades, lowest grades. So that's what the different colours in the background show. These points on the map are schools, and as with all neogeography websites, you can zoom in just with a double click, and you can drag the map around, panning and zooming as you go. Now, with this particular website, if you click on one of the schools, we've actually developed outside of the Neogeography website a way in which we can model the catchment area of schools. So in this particular example, John Bunyan School, you can see where the students who actually attend that school live within this zone. We haven't disclosed the locations where any particular students live, so you maintain sort of data disclosure. You maintain safety in that you're not going to disclose the location of any individual pupils. And you can build in other sort of interactive features into the map. So we might, for example, want to swap the 5A to C data for the percentage of preschool meals, which is 10% over. Or we might want to look at the A-level point score. And you can imagine these types of information would be quite useful if you were looking to target courses at university. The other thing which has got in it is the percentage of people, or the proportion of people rather, doing different types of A-level subjects. So you can see here, if you were doing a mail shop, for example, as a local college, and you wanted to get more people to do English in your particular college you just selected, you might be better off sending some of these mail shop flyers to these particular areas here, the dark blue ones, where more of the students who particularly do English live. So, you can basically, taking raw data, you can build up these nice pictures and you can use them to tell stories which have got real-world applications as well. Oh, one more thing about this website as well, which you can do. For the schools that do both GCSE and A-levels, you can look at the different catchments together, so you just switch them like this. So that's an example of a type of neogeography website where you would take raw data, some sort of processing would go on behind the scenes, and you put it into one of the interfaces and people could browse it and interact with it in a way in which you couldn't necessarily do if you just had the raw data files themselves. Now, that's fine. The other types of data that people might typically have, and this was another project, again it was funded by the ESRC, was how you can bring in sort of pre-made cartography, if you like, onto modern day sort of web interfaces. So this is the Marr map of Manchester. Now Thomas Marr wrote a book called I think it was the Housing Conditions in Manchester and Salford. And he represented a group called the Manchester Citizens Association. This was from 1904. And what this map shows you, I'll just fade this up, are the general conditions from his survey of what he observed the living conditions to be within these different parts of Manchester. And it's actually a really nice, if you can get the book out of the library, it's a really nice piece of cartography, and it's the map sort of folds out. So that's great, but we thought, well, it'd be much nicer if you could browse it online and look at it in relation to some sort of the modern street layouts. And also what essentially a modern version of what this classification did. This was sort of a qualitative study, so he went round and observed the different types of neighbourhoods and colour-coded them by these different groups. You can see here, this is central Manchester, it's dominated offices and warehouses. But if we sort of zoom out to the suburbs, you can see it's brown, yellow and green, and then it's more in line with sort of suburban houses with gardens, for example. A modern day equivalent of this type of sort of area classification is something we call geodemographics, which takes lots of raw data about the people and places of small area geographies, and it finds groupings of areas which share similar sorts of characteristics. One particular example of this is the National Statistics Output Area Classification, which again we've laid on this website here. I'll just fade this up. Using this button, you can actually swap between the two layers. And what you find is there actually is a reasonable degree of correlation between the groupings of neighbourhoods identified on this old map and those which are sort of identified on this new map. And that's partly because certain types of building structure lend themselves to certain types of occupations. So areas which were typically warehouses in the centre of Manchester, obviously through gentrification, are more likely to turn into flats which attract a certain type of people. So the patterns of the past influence sort of what we see on the ground now. And again, you couldn't necessarily have got that information necessarily from having all these separate data sets. Neogeography is the way in which you can bring these different data sets together. And that's really the advantage. As I said, these are sort of reasonably technical solutions, but there are simple ways in which you can bring these together in your own research as well. Okay, so over to Karyn.
My name is Karyn Morrissey and I'm one of the new recruits, so I'm quite new to the University of Liverpool and the UK in general. So that's why my example is going to be based around Irish data, but it's still as applicable. Now, both Alex and Chris have kind of led up in a very convenient way to what I'm going to speak about, whereby they've spoken about available sorts of data, what you can do with that in terms of analysis, but they've also sort of hinted around sort of policy applications. And what I'm going to actually speak about today is a specific policy application of quantitative analysis, because unfortunately for people that like to develop models such as myself, we're not really allowed, we won't get paid to just go out and develop a model without a sort of raison d'etre. And in this case, my reason was that I wanted to analyse health policy, and specifically health policy in Ireland at the small area level. Now, in terms of health, health is a particularly interesting policy area because unlike other policy areas such as crime or such as education, at every point in one's life somebody is engaging with the healthcare system of their country. So usually after the age of, sometimes at the age of 18, sometimes at the age of approximately 24. In my case, I've never left university. People will actually buy out of education. In terms of crime policy, not everybody is thankfully going to be hit in terms of crime. However, with regard to health, throughout one's life course, one is always going to use healthcare services, even if it's just in a preventative manner, i.e. vaccines, etc. So healthcare policy in general does attract a lot of research, which is fantastic if you're interested in that specific area, but it also means that it's quite a contentious area in terms of policy, and when one addresses a health issue or a health policy, one needs to make sure that their model is particularly robust. And one of the ways in which one can actually ensure that data is robust or even available is through quantitative methods, and through either using data that's there, which would be great, or simulating your own data. So just a little bit of background in terms of health numbers and basically geography and how they all kind of impact on each other. So as I said, health and health is an individual property. I cannot generate health for another person, and this is in general. Of course, through organ donation, etc., you can potentially, but for the most part, by me running and eating well, it's not going to impact on you guys. But however, and while health and health outcomes are to a large degree predetermined through genetic makeup, we all have a certain propensity at birth to be healthy, some of us to a greater degree, unfortunately. However, the health outcome of an individual can also be socially and environmentally constructed. And this is where policy and health policy can come into play and be incredibly important. Because for the well-being of individuals, and when you aggregate that up to the whole, to the nation, it, you know, the healthiness or the productivity at a very cynical level, the amount of output as a country that we can generate depends on the health of our actual employee population. So to ensure that we are productive and that our output just keeps going out there, it just keeps spilling out, it is important for policymakers to determine what are the social and environmental factors that impact on individual and at the aggregate level, because we are a nationality, a nation is the sum of parts. What are these factors that determine health? And generally there's a consensus, if you can imagine any sort of consensus among academics, that there are two broad ways in which geography, remember I am presenting this across space, geography can impact on one's health. And this is through what I'll briefly say individual characteristics, which are in academic terms called composite characteristics, or it's down to place characteristics, or in academic terminology, contextual characteristics. In terms of individual characteristics, individuals cluster in space. Remember, bringing this back to geography, individuals tend to cluster in space around areas where people are like themselves. When I first moved to L1, I wasn't really going to, I didn't feel, or when I first moved to Liverpool, I didn't feel I fitted in the demographic of those out in Singleton Park, i.e. I was young, I didn't have a family, I wanted to be mobile because I was travelling back and forth to Ireland quite a bit, so the city centre for me was is where I chose. And if I look around the people and the people that live in my particular area, we all tend to be young, we're all semi-professional or at least professional, and we all seem to just leave en masse on the weekend and just go elsewhere. So, you know, this kind of area suits me, and it's because the people in it are like myself. While people out in Singleton Park, for example, or Shefton Park as I thought it was once initially pronounced, these tend to be more, looking at the demographics, a little bit older, married with children, so maybe perhaps, you know, they're around a bit more. Now that's in terms of individual characteristics. That means that people have a propensity to group together in the same area. But what it also means that given health is a product of one's age, it's a product of their sex, of their gender, and it's also importantly a product of their income level. Various studies on health have indicated that income level can generate as much, the level of income you earn or your socioeconomic category can be correlated with your health status up to about 70%. So what you earn, of course this makes sense because it allows you to buy health to a certain degree. So this means that given these people of these same categories clustered together, this also means that the health at the aggregate level of an area may also tend to be similar. So when I look at the people where I specifically live, every single night where somebody's out jogging, you know, they're in a position to be able to engage in health benefiting activities. Now, and this all makes sense. Right, standalone, these characteristics will impact on your health. However, there's also another theory that it's not just the individual that actually is able to generate health or encourages personal decisions to be healthy. The place that you live in will also generate a certain amount of health benefiting or health negative health characteristics, and this is all down to the idea of peers. Basically, if you live in an area where everybody smokes, it's suddenly normalized that you smoke. Everybody's doing it. If they're doing it, it must be okay. However, if you live in an area where everybody is running every night, I know certainly sometimes I come home in the evening, I'm like, it's too windy, not running, no way. And yet when I'm going up the staircase to my apartment, I see 3 other people going back past me in their jogging gear, and I think, well, if they can do it, I'll do it. So certainly the places where you live can have an actual impact on your sort of on how healthy you are, because places are a sum of individuals, and we as peers tend to sort of we like to associate ourselves with our peers around us. So if you think that it's okay to smoke, everybody else is doing it, you will actually probably have a higher propensity to smoke. So regardless of which theory this is, rather that it's all individual or it's all place, it all just depends on where you live and on those around you. Doesn't really matter. What does matter for policymakers, this is an academic debate. This is pure, it's a pretty, you'd be amazed how excited people can get over these two, which is right and which is wrong. But in terms of policy, what does matter is that place does impact on one's individual health, and that has knock-on effects for the health of the nation. So now that we know that health actually is not only individual specific, but it's also can also be place and spatially specific, we need to ensure that our data is actually spatially referenced. So it's great to have a data set that actually tells you that individual A is healthy, individual B is healthy, individual C is healthy, but not D. But what does that tell you? There's no geo-reference here. It doesn't tell you if specifically L1 is healthier than Sefton Park. And if you're a policymaker, and currently, particularly given the current cuts, if you're trying to target your scarce resources, you want to ensure that you're setting up a health clinic in the area that is most likely to have unhealthy people. So this is where sort of quantitative methods come in, and sort of quantitative analysis, because for the most part, unfortunately, most data is not spatially referenced. It's only in the last 20 years that health geography has become of interest. So what we need to do is go back a step and basically generate this data ourselves. And one of the means in which you can do this is via spatial microsimulation. So what this basically does, it brings together a spatial data set and a non-spatial data set. So spatial data, such as the census, will generally have information on age, sex, one's socioeconomic status, but it certainly won't include sort of rates information on health, because this is too it's first of all confidential, and second of all, nobody wants to bother. Like, the census form takes 15 to 20 minutes anyway. Having another section just puts a higher response burden on one. So generally, census data doesn't have health information, so therefore we needed to bring it together with surveys that do have health data. So spatial microsimulation, I won't bore you with the algorithm, basically overcomes these difficulties by using a statistical algorithm to produce geo-referenced health data. And in terms of my research, the particular model I actually use is called SMILE. And unfortunately, it was basically the love child of my PhD, and at various times the acronym was called SLIME, SMILE, whatever mood it was in or I was in. But what it does do was allow me to produce one of the first actually the first small area profile of long-term illness in Ireland. And this is basically it. Just to give you, this is Dublin here. This is and these here, this is Galway, Limerick, Cork and Waterford, and they're basically the big urban, well, if you can say big and urban in terms of Ireland, but these are the urban areas. And what you're going to see is that in terms of long-term illness, that these, it's very much specific to certain locations. Dublin is quite healthy, while those in the northwest and down around the west, and especially in the south and down in the southwest, these people here tend to be unhealthier, or at least report higher levels of long-term illness. And when you look at other data, you can see why. Dublin is very young. It's a very young population. Most people are professionals. Before the recession, we had a financial sector that was way overemployed for obvious reasons. And that means that a lot of people in this area, around the Dublin area, were employed in these kind of higher education institutes or companies. They tended to be younger, they tended to be more aware of health generating activities and therefore engaged with them. However, the northwest, the west and the southwest it's an older population. People by lieu of their age are even like the average age for Dublin as a whole is something like 33. When you look at Donegal, that moves up to 40 because you know the older age groups skew that up. So skew the age distribution forward. So this means by even lieu of age that more people are going to report long-term illness. So effectively, what we're able to do using this simulated data is create a profile of health in Ireland, and therefore allow policymakers to target perhaps health policies or at least maybe healthcare services to areas where they need them the most. It's quite clear here, for example, that perhaps any new hospital wouldn't really gain from it. Any new maybe primary care clinic on a substantial level, well, they're not going to have as many patients as it would if it was located up here. And really, in terms of policymakers, if you're going to spend money, you want bang for buck, so you need to follow the distribution. Now, that all took a lot of effort and a number of years off my my own life expectancy, I imagine. So what you can also have in certain instances, and what both Alex and Chris spoke about, is data that's already there, and that is the bee's knees. All you have to do is, well, there's still a lot of work involved, but you can get straight down to the modelling after a while. So for some policy areas are more aware of space than others. And what we found when I was doing my PhD in Ireland, what I found was that psychiatric data is already geo-referenced. So I was able, after about 18 months, because as you can imagine, if health data is confidential, psychiatric admissions to an acute psychiatric hospital is even more sensitive. And unfortunately, for the institute that gave it to me, after a lot of toing and froing, they finally gave me the rights to use the data, but also gave me the mobile numbers of each and every patient, which was really a cock-up on their part. So it kind of goes to show the dynamics that sometimes work out in accessing data. And I also never told them that they gave me the mobile numbers, because they'd have taken it right back off me, just press delete. So, so in terms of this, in terms of the psychiatric data, I was very, very fortunate to be given this spatially referenced data. So I didn't have to go through this convoluted, more convoluted pathway to being able to look at the spatial distribution. And this specific map shows you specifically how admin data, and if you just put a little bit of thought into how you set up your an actual service sets up their data, can be used for further policy analysis. So this basically shows you a map of depression per 100,000 in Ireland. And as you can see, whilst Dublin was very much physically well at the aggregate level, what you see here is that actually there is quite a high proliferation of going from east to gradual going from east to west in terms of accessing psychiatric services. But if you can see it, these red dots, these show the location of hospitals. So it's also using this quantitative data and other data sources, I was able to map the actual location of acute hospitals, psychiatric hospitals. And if you notice the areas that have very high rates of depression, they're also in areas that tend to actually have a psychiatric hospital. So it may actually be service driven, which is a good thing. People that need these services are accessing the services, but it can also mean that these people up here are unidentified individuals in terms of having depression. So what's important here, as Chris pointed out, is by looking at this map with just rates of depression spatially, you think, well, you know, a lot of people here have issues, but not so many people here have issues. Let's not put a service out here. You know, that's what this first initial sort of sub-layer would show. But then when you overlay that with further data and get more to the point, you see that actually it could be potentially because individuals here just have access to the services. So perhaps further analysis is actually required up here. So, what's very, very important when you are using quantitative data is to make sure that you look at all perspectives, because if not, as I said, health policy is hugely contentious. To make an apt recommendation, there's so many dimensions one has to take into account that, it really is important that you look at outside the box to a certain degree. And doing this, and the fact that we are able to reference this spatially, and down to the Neogeography techniques that Alex discussed, it does allow policymakers to develop more focused policies. And I think that brings me to a conclusion, and Hill is going to speak about, I think, life course analysis. Thank you.
So, ladies and gentlemen, my colleagues focused on spatial and gave you an overview of the virtues of spatial analysis. So they are geographers. I'm going to focus on time because I'm a demographer. So I'm going to tell you about advantages of using life course approach and longitudinal data in social research. And let me begin with life course approach. If you look at social research, we can still say that most social research investigates people at one point in time, at survey or at census. We describe distribution of population by various characteristics, and then we examine the relationship between characteristics of individuals in order to understand what influence human behavior. This is okay. If we wish to gain a deeper understanding of the causes and consequences of an individual's action, we need to adopt a dynamic approach. We need to explicitly study changes over lives of individuals and how individuals' life path change over time. So let me give you a simple example from migration and integration research I'm interested in. Imagine a young man born in country A and moves to the UK at age 20. Assume he first cohabits with a British-born girl. This partnership lasts a year, and then he becomes separated. You see another box there. Next, he cohabits with a woman from country A, which is from the country where the man comes from, and then marries this woman. So what is the story here? Following changes in his family life tells us much more about opportunities and constraints the migrant or this young man faces with compared to if we only look at his first marriage or his status is at any other time point. And first marriage is what usually we find from statistics and what researchers tend to present. Of course, there may also be changes over time. A simple cross-sectional analysis might have been sufficient to measure family dynamics among migrants well in the 1980s when a migrant was either single or married. But the life course approach is needed to understand migrants' family lives in more recent periods. And please note here that the question is not just about a more or less complex patterns or more precise measurement. Rather, the life course approach or analysis provides us with a context to understand the migrant experience or these transitions, what he or she experiences. Let me give you another example. We know that UK-born Pakistani women have relatively high fertility levels. On average, 2.5 to 3 children per woman. And the UK level is around 1.8, so that had actually increased during the last decade. And this high fertility of UK-born Pakistani women is usually explained by cultural factors. A tendency of people of Pakistani ethnic origin to maintain the family patterns of their or their parents' country of origin because of religion and other related factors. Again, a closer look at, lives of British Pakistani women may improve our understanding of this behavioral pattern. For example, we may observe the pattern as follows. A woman leaves the school at early age and then becomes unemployed. This is a fortunate story. During the unemployment spell, she becomes pregnant and her first child is born. When the child is about 3 years old, she receives a short-term job. But this is just a short-term job, and after that she becomes again unemployed. And in fact, inactive, which means that not looking for a job anymore. And then a second and third child are born. What conclusions we could draw from such analysis? Very simple. The high fertility of women of Pakistani ethnic origin may be an outcome of their poor labor market perspective. Therefore, given this context, they may decide to choose the so-called motherhood track in order to find a meaning for their lives and justify their lives for others. Again, we may observe changes over time. Assume that, sorry, this is a little bit complex picture, but I explain it. Assume that the life course pattern I just described is still reality, and this is the one here. But in a few years' time, we will observe some changes. The length of education has increased for women of Pakistani ethnic origin, and their labor market performance has improved. And fertility has also declined. So they have, the average pattern is they have 2 children instead of 3. And they improve labor market performance, maybe a result of government policies from the early 2000s. First, to improve the British educational system, and second, to encourage women with lower qualifications to work rather than stay at home. Okay, now about data. Also, the colleagues talked about spatial data, and I'm going to just tell a little bit about longitudinal data. So, in order to adopt a dynamic approach, we need longitudinal data, and longitudinal studies provide such data. There used to be small-scale studies, but during the last 10 years or so, large-scale longitudinal data have become increasingly available. And these are particularly interesting because, or useful because, these provide information on life histories of a large number of individuals, and also reliable information on population subgroups, including immigrants, high focused or ethnic and cultural minorities, whose numbers tend to be small in the conventional surveys. You probably have heard about excellent registered data in the Nordic countries. So what about data availability in the UK? I think situation is very good in terms of international comparison. So first, we do have the ONS longitudinal study, and this study was launched in 1971, and it included linked census and vital events data on 1% of the population of England and Wales. But this 1% is still representative and large enough to conduct detailed analysis. The data include full marital childbearing histories, also international migration is included, and I have recently learned that there is also complete histories of certain type of cancer, which is interesting for those who are doing health research. Information on education, employment, housing histories, ethnicity, and so on are from the census years, and these vertical lines are to denote census years. And you can, of course, have also contextual information or information on their residential context from census time. And in this sense, this data set has been used increasingly by social researchers, particularly those doing health research, but also it has become popular in family fertility research. And one interesting study has been published some time ago on social mobility of second generation the descendants of immigrants in the UK, following them from the 1971 to 1991. If someone wants to do, can follow from 1991 to 2011, which data hopefully will be, census data will be soon linked to this data set. There is another interesting or large-scale longitudinal study in the UK called Understanding Society. This study was launched in 2008, and here information is collected on major life events and domains of individuals. Further information is collected annually on values and attitudes. And by exploiting these data we can easily investigate the relationships between, for example, partnership choice and changes in values and attitudes. And I have drawn a diagram to show some ideas that one may wish to explore and then try to understand whether values influence a partnership behavior here, or rather partnership behavior influence values and attitudes. And I think that these causality is always difficult to tease out, but it's still possible to make a step further here. So, if you're interested in life course approach and longitudinal analysis, you are welcome to participate in a course on event history analysis, which I will teach next May. And finally, I just wanted to show you life course of migrant life of a migrant in the UK. So thank you very much.